Yeah, so welcome to the last week, everybody. I'm glad you're here, and I hope like the past 5 weeks have been a lot of fun. We're just going to go over a little bit extra stuff this week, and then we're going to talk a little bit about sort of a show that we're going to try to do for everybody at the in about 2 weeks. So basically, like the idea is that we'll have like a light optional live stream to present. So if you want to invite friends, family, whatever, we'll set up a Moises, Leah, and I are going to set up a little stream. Actually, oh, there's Moises. Okay, he's on his phone. So we're going to do a live stream. Actually, let me share my screen because you guys can't see anything. So we're going to do a end of class like showcase, show and tell type of thing. It's going to be 2 weeks from today. It's going to be about the same. It's going to be this time. So we'll host a YouTube live stream. I think I'll send out the link a little bit later today. So Leah's already added signups. So if you want to sign up for a slot, please feel free to do it. Like, 5 to 7 minutes. So think about if you want to do something live, like if you just want to actually like demo your thing, or if you want to record a video of you talking, or you just want to record a video and you talk over it while you're playing the video, like those sort of things. This is optional. So like no one is required to do public speaking. I know everyone has different feelings about public speaking. So I think it'll just be a fun experience and like a way for everyone to share work. I know a bunch of my friends will probably show up who are also artists and stuff. So it'll be a way to get a little bit of exposure about your work as well. And yeah, I think it'll just be fun way to hang out and just sort of like cap off the week. Cause a lot of this is like, I've given you we've talked a lot about 5 weeks of class, and we've thrown so much information at you that it's hard to imagine that you would have a final project for this actual like week 5 of class. So this gives you an extra 2 weeks to just sort of like keep churning on things and then maybe present some stuff. So I think it'll be pretty fun. Moises is helping handling all the AV and tech stuff. So basically sign up for a slot and then we'll reach out to you and sort of figure out how you want to present. And then we'll figure out how to manage all that. But I think it should be a fun time. It'll be like pretty low key, but also just a nice way for everyone to sort of show what they've finally been working on. I think we've seen a lot of stuff in Slack, but it'll be nice to sort of just have like, here's what I made and like, here's what I try to do. And I think it's important to also talk about like what you failed at. Like, feel free to be like, this didn't go as well as I wanted it to, and here's why. Because I think like, as I've said before, like there are so few people working in this sort of space that like, even your failures are like big learning opportunities for everyone else. Like, I have personally enjoyed watching some of you struggle a little bit because it helps me understand, one, what I can be doing better in terms of instruction, but also two, like sometimes I've never seen stuff fail the way you guys have had it fail. So like that is helpful for me to know, and that is helpful for I think the StyleGAN community to know as well. So we'll talk a little bit about that more. But I just wanted to mention this before. We'll mention at the end of class as well. But yeah, just start to think about like maybe what you would want to present. It doesn't have to be 5 to 7 minutes. If it's like a 1-minute demo that you just want to show a video, that's totally cool. Like totally optional, and we don't want anyone to feel pressured about like having to present like perfectly or whatever. Like you've seen me present, I fuck up all the time. So like feel free to just like, talk about your work, and that's all that's really important. Today we are going to look at mostly at feature vectors. So I'll talk a little bit about what feature vectors are. Then we're going to play with GANSpace, which I think some of you have maybe already started to try to play with. I fixed up the notebook a little bit, made it a lot easier to install everything. So I'll walk through how to do that. And then we'll basically, once we get our feature vectors, I'll do one last demo that is basically like, how do I apply feature vectors to something like audio? So we looked a lot at audio last week. This time we'll just do a really simple demo, but this time we'll do it with a feature vector. And then at the end of class, I'll talk a little bit about next steps. I know a lot of you have been interested in how do I keep learning at this stuff. So I've got some resources on where to learn, who to learn from, what communities, what people to follow on Twitter, those sort of things. And then I know some people are maybe interested in like, if I want to build my own machine, what do I do? And maybe I'll spend a little bit of time during Q&A to talk through that. I just finished my second deep learning machine this morning at 6:30 a.m. So I can tell you a little bit about what getting CUDA and everything installed was definitely not my favorite part of the experience. It never is. I know Martin, I think Martin is trying to build his own. It will be a journey. Basically, hardware is a whole other world, and I don't recommend getting in unless you're like really, really hardcore into it and willing to like lose a couple of days of your life trying to figure stuff out. But if you're interested, I can talk through that. And then maybe some other things that people want to know about in the Q&A. One other thing I want to mention is Esteban and I have also been talking about, we've been talking a little bit, everyone has been talking a little bit about it, like how to actually close out your GCP account. So I recommended that you delete your virtual machine. That is still my recommendation. Like you definitely need to delete your virtual machine or it will be charging you like a storage fee. But I also noticed that there is a way in GCP to actually close your billing account. If you just go to billing and I think at the bottom there's something like settings, you can actually close your billing account and that makes sure that they can't even charge you anymore. So even if there was some weird fee they want to charge you, like they could, you know, once you've closed your billing account, they can't do that. So I'll send out just a screenshot of what that looks like. But I definitely recommend, like, if you know you're not going to use GCP anymore and you like are done with everything, definitely close out as much as you can because they will always find a way to charge you some sort of fees unless you close your account entirely. So I definitely recommend doing that. And I just want to make that note before we get usually what'll happen is that like in a month from now, people will DM me and be like, hey, why am I being charged? And it's sometimes in that is like explicit about like you have to shut it, you have to delete your virtual machine and close your account, like those sort of things. But obviously I don't want anyone to be charged more money than they need to be for these classes. So just remember to do that. And like I said, I'll post that in the notes for class and in Slack. So any questions before we jump into the feature vectors? All right, I will take silence as a no. Let's get started. Okay, so feature vectors. So again, remember that StyleGAN uses 512 dimensions, and that is sort of this dimensional space. If you've actually taken one of those seeds and maybe printed it using Colab, you will see it's literally an array of 512 numbers between -1 and 1. And it's a long float number. It's like actually hard to actually print out every one of those numbers, but you can. So when you hear machine learning people talk about what those 512 dimensions are, they will refer to them as features. And what do we mean by features? So by features, we mean something that is like noticeable in a model, right? So like, let's say it's a face model, right? And there's hair length, there's eye color, there's nose shape, there's mouth shape, there's background, there's any one of these things. So you might assume that each one of these vectors in the 512 dimensional space controls features that we as humans would recognize. So maybe it actually, maybe like vector 1 in the the 0 space controls hair color, and maybe vector 444 controls eye color. Unfortunately, that's not really how it works, in part because machines don't look at things the same way that humans do. But also because of, if you remember, we talked about this, I think 2 weeks ago, entanglement. So in the Z space, you know, if you're going from the person on the left to the person on the right, like you would ideally hope that like it would be a very smooth transition and you wouldn't get things like eyeglasses popping up. But unfortunately, with the way that machine learning sort of fills these Z spaces, is you get what is called entanglement. And that's what you see sort of on the top screen. The bottom screen is better, but there will still be things that are called entanglements in those. So you might be like, let's say, and I've done this before, you might take just the second vector of your model and animate that from -1 to 1. It's never going to be like exactly what you think it is. It's going to be something weird, and it's going to maybe be partly hair color and partly background and like a couple of things. It's very entangled. And some of that's just because that's how the machine has figured out the best use of space and like what sort of compression works, because it only has 512 dimensions to manage, you know, I don't know what 1024 by 1024 is. It's a very big number. So to manage all those pixels, like it has to figure out ways to make things work together. So feature vectors. So when we talk about machine learning and you hear someone talk about a feature, they might be talking about an individual vector. In the artist community and maybe more in the GAN space, you will hear people talk about feature vectors as something that actually a human would recognize. Like, so when I talk about a feature vector in this class, especially this week, it's going to be more about those human readable vectors. And that controls ideal characteristics. So again, hair color, eye color, complexion, you know, any of these sort of features. And there's a couple ways to find them. So the old way that people used to find them is they would literally like plot in a bunch of different, they would plot out, you know, 10,000 images, and maybe they would go through all the images and they'd pull out just the ones that changed eye color from green to blue or from green to brown. And they would literally tag all those as like green eyes, brown eyes, green eyes, brown eyes. And then they would feed them through another machine learning model that was a classification model. And that classification model would basically like figure out where they belong in the space, right? So you map your features to your vector space, and then it's basically like it's almost a 2D interpolation, or like just a 2D line graph in 512 dimensions. You know, that's something that like machine learning is very, very good at. It can take that data and sort of plot a line of best fit. So again, let's say like, you know, the features we want to pull out are the ones in yellow, the ones we want to avoid are the ones in red. So you could even tag things as like, I don't want, I don't know, I don't want blue eyes, I only want green and brown eyes. So again, a machine learning model could sort of learn like how to draw a line of best fit. Now that's pretty annoying, right? You have to do a lot of manual work. You have to tag images. You have to like try to figure out where these images belong. Like, you know, are you trying to take things of only, you know, only people with long hair, only people with short hair, like those sort of things. It's a pretty labor intensive process, but people have done it. And there are some vectors available online. If you're interested in just working with FFHQ, which is the face model, there's a good, I think, I'm trying to think about who, like some people just have a bunch of different vectors. The open mouth one is one of the most popular ones because it's like pretty crazy to watch. You can open people's mouths and close their mouths using just a feature vector. But that's one way. The next way, and the way that is sort of that just came out, like, so literally GANSpace was released right when class started, right? So like it's been like 6 weeks now. So what they use is a technique called principal component analysis. You'll hear this referred to as PCA. We obviously don't need to get into exactly how PCA works, but if you see these red dots, the point of PCA, and this is obviously in two-dimensional spaces, is to spread those red dots as evenly or as far out as possible. So this pink line here actually determines the PCA because that is where the line of where these red dots spread out the furthest. This is basically a mathematical process that takes all of your data and it can, basically what we use PCA for is to project our images. You'll hear it called project, which is different from projection, which we've done in a previous class, but like you'll hear people talk about projecting down smaller dimensions. The idea of PCA is that you can basically go from 512 dimensions down to 1 or 2 or 20. It's just a mathematical way of just compressing all your layers. So GANSpace uses this, and what GANSpace does is it basically like takes those layers, it takes the 512 dimensional layers, and then it compresses them down to certain components. And the way these components work is that the very first component, which is called component 0, will contain the maximum amount of change in a data set, right? So it's, again, it's that first, it's this image. So early components will have like rather big changes in them. So in this case, you see here, someone is sliding across the component 0, and that changes, well, okay, component 1 changes the car direction. This is using the cars model. Component 2 seems to change zoom scale, other things. So your top layers will contain the most amount of change, and your later layers will be more detail oriented, or, you know, this will be probably more like, yeah, so here you're seeing sort of mid-layer component 8 or 9, changes a little bit of the shape and a little bit of the background, but the car color itself doesn't change, right? That sort of thing. Here you're seeing component 21. This is going from gray to red. And then you'll see the latest components, component 85, are like very minor details. So I'm going to show you how to set up GANSpace today. It's pretty easy, actually. Like, I find it fairly simple once you go through the steps. It doesn't take that long, which is pretty great. So we're going to try to see, like, based on our custom models, what GANSpace finds as the feature vectors. So as we go through GANSpace, you'll see it'll produce images like this, which is a grid of sort of different components. So along the left-hand column here, you'll see C0, C1, C2, C3. Anytime you see anything related to C, that means a component. So again, C0 is what the model found as the maximum amount of change between these layers, right? So let's take a look at this in closer detail. So you'll see C0, describing these as genders, but it's clearly like going from a male presenting face to a female presenting face. There's obviously more than one gender, and like that we can, I hate that I have to describe it as this, but it's basically, you know, person on the left has facial hair and short hair, person on the right does not, with long hair. So this is what it described as the most prominent, largest change of component. At C1, C1 is actually really interesting. Can anyone guess what this is actually describing?
It's like how symmetrical it is and on what side the symmetry comes from.
Yeah, exactly. Yeah, so this is really interesting. So remember that FFHQ is like 70,000 photos from Flickr, and all they did was tag stuff by face. So they actually, so some of their faces are profile view. They're like this, and other ones are like this. So GANSpace actually found the second vector controls found a vector that controls profile. So in the middle, you have a direct view. On the left, you have sort of I'm not even gonna try to describe directions from this, but essentially you have this profile and on this profile. Now what's important to realize here is there's still entanglement, right? Like we might say like, oh, if I want the person on the left and the person on the right, shouldn't it be the same looking person across this? And unfortunately it's not. And this is sort of like one of the things you'll find with StyleGAN, like all GANs in general will always have some entanglement just because you're basically compressing all these features down, and there's no like what we would call an autoencoder layer that actually like keeps what these people look like across all these things. But it's still helpful to know that like maybe I could actually take a certain face and try using this vector to actually turn its direction, right? It doesn't always work like that, but it'd be pretty interesting just to sort of see. Maybe you could take a face of a famous person, bring it in using projection, and then use this vector to actually see if you can animate their profile. So these are still entangled a little bit. There's no way to really get around that, but this is really interesting in that you can start to see like maybe there are ways to manipulate my model outside of just like playing with vector dimensions and like, using either something like the near neighbor stuff I demoed yesterday or last week, or, just randomly generating Cs and see if you get this person again with a different face. So this is getting closer to like a fine tuning where we can actually really take a particular point in space and then maybe manipulate a little bit more while still keeping a lot of the salient features we want and only changing the features we really want to change. So this is C0 and C1. So this is the first component it found, which means it's the maximum amount of change. Let's look a little bit later in the network, which is C8 and C9. C8 almost looks like a age vector. So here on the left is a very young face. Here on the right is an older face. What I think is interesting here is it also adds glasses, which probably makes sense, right? Like the older you get, the more likely you are to need glasses. Although I've had glasses since I was like 7. But for a lot of faces, like they probably in a lot of the Flickr data. And again, remember this is all based on the data set you provided it, right? So if you were to provide it only faces of children with glasses, it would learn that children always have glasses. Whereas, this was trained on a large data set using Flickr, so it was pretty wide, although it still has a lot of biases in it, and it's important to remember that. But it did sort of learn that like older people generally have glasses. So that's helpful to see. C9 is, again, some of these are actually hard to describe. Like you could describe like maybe it's complexion, like this person has a little bit of more of an olive skin tone. Maybe it's also like a hair vector that helps you like understand who's got curly hair and who's got straight hair. Again, it's important to remember that these are machine made decisions, right? So like as a human, or as a human with my own biases and my own way of looking at faces, I might say that there's no clear vector in this description, right? It kind of changes backgrounds, it changes hairstyle, it changes skin color a little bit. But it's still helpful to know that like, okay, if I want to interpolate with C9 and I have a face that is maybe my face, if I go in the negative direction, maybe my hair will get curly and maybe my skin will get a little bit darker. If I go to the right, maybe I'll get a slightly longer hair and maybe like a weird like rocky, blurry background. This is just kind of like this is all pretty new, and we're just sort of figuring out like how this stuff works. And there's a lot of people within the GAN community that want to make these far more editable, right? Like we can imagine a world in which like if I could take my face and then stick it into a GAN and then manipulate any number of vectors, like that would be a really huge like sort of feat, right? Like right now you have to sort of do that through like 3D modeling, which can take a long time. This is, once the model is trained, like this takes about 10 minutes to produce. So there's a lot of opportunities here, even if it still isn't perfect. So it's worth sort of exploring. So here is GANSpace with one of my models. This is my floral model. And you'll see it's like, you know, human faces, like we've all been trained to sort of read how human faces are different. Taking that into one of your custom models is really interesting and like kind of hard to figure out what some of this stuff means. So at the very top here, like I actually have no idea how to describe C0 to C2. Or sorry, C0 from -2 to 2. Maybe it's like direction of flowers and maybe it's color. Like this is very entangled, right? It's a little bit harder to sort of say exactly what's changing here. Whereas if I look at, excuse me, C12, C12 almost looks perfectly disentangled and is going from purple to red. Like that's pretty amazing. Like that alone, having that ability without having to tag a bunch of my data like all over the place is really, really cool. So I created, you can also create videos using GANSpace. So here's a little video of what that color shift looks like. And so you'll see it's not perfectly disentangled, right? There's a little bit of like leaves and foliage that was coming in. The flower shapes are changing just slightly, but still like this is, I mean, if I had to do this manually to try and find this vector, I would never find it. Or if I had to find how to interpolate between these two shapes, I would never be able to find it. So GANSpace allows us to sort of like very quickly sort of see what is more available in our space, and then maybe we'll begin to tweak some of those images and really play with those vectors in a way that we haven't before in other places. Here was one on a very quickly undertrained bird model. And this actually feels like, I described it as the bird size vectors. So it goes from very small birds to very big birds. So this is the big bird vector. So again, PCA and GANSpace found these themselves, which is pretty amazing. So it's like, you know, it might not be perfect in many ways, but it is really interesting that what it does find is really, you can begin to play with and explore. So this is another tool in your tool chest, in addition to like interpolation, in addition to projection, like all these things. So we're sort of like, the GAN community is beginning to build out more and more of these tools that we can begin to utilize for our own images and video making processes. Okay, yeah, let's get started. So I'm gonna show a demo of how to do this. The link is here. It is a Colab notebook. It was written by a person on Twitter called Real Meaty Human. His name is also Sid. He's been walking me through a lot of how this works, and it's been really, really helpful. We're gonna go ahead and get started here. So when you come to the notebook, the first thing you wanna do is you wanna make sure you're using TensorFlow. I'm gonna go ahead and just run this command here to just get us set up on Google Drive. I've been having lots of issues with Google Drive this week where it like doesn't ever end up connecting. So just be aware that that might happen. It'll be fine if it does, but hopefully it connects this time. Cool, it did. All right, so once we have these two pieces connected, the next thing we need to do is install some stuff. And this is gonna take a little bit while. This will probably take about 5 minutes. So if you have questions, we'll take them while we're loading this stuff up. First thing it's gonna do is it's gonna download and install GANSpace. And then it's gonna install a couple of dependencies. This cell should run pretty quickly. It's this cell that's gonna take a while. Basically, this cell is going to install a thing called PyCUDA. So one of the things we'll talk about is that GANSpace is written in PyTorch, whereas our traditional StyleGAN 2 models are written in TensorFlow. So we have to do some weird conversions of our models to go from TensorFlow to PyTorch. So this installs a bunch of PyTorch materials. So also TensorFlow, as you should know, is a Google project. So basically Colab is gonna work way better with TensorFlow because it just like default installs all that stuff. Some PyTorch things are already installed in Colab. So if you have a really basic PyTorch notebook, you'll be fine. But because this installs PyCUDA and a bunch of other things, this is gonna take a while. This is gonna take about 5 minutes for this to install. So maybe while this installs, I'll walk us through the rest of the steps in the notebook, and then when this is finished, we'll come back and actually start doing it. So there is conversion of your model weights. So again, you have pickle files. Those pickle files are your models. Those are pickles. I don't think they're entirely specific to TensorFlow, but they're more commonly used in TensorFlow than they are in PyTorch. So what we're going to do in this step, which I actually won't do here because it's like longer than necessary and it's pretty straightforward. I'm going to convert a pickle model to a .pt model, which is a PyTorch model format. This is pretty simple. You just bring in your pickle file that you want to use. Then you are going to clone in the Skyfly nil repo. You can bring in any StyleGAN 2 model. It really doesn't matter here, but we're just going to bring in the Skyfly nil one for this case. Then you run this command, and this command just says, basically you're going to run a script inside of your GANSpace, in your GANSpace repo. And all you're going to do is say, hey, I've got this StyleGAN model that is in TensorFlow. Here is the link to where the TensorFlow StyleGAN 2 model is, and then here's the pickle I want you to convert. When you run this, it will just convert. It takes about 5 minutes. It's going to convert your pickle file to a .pt file. And basically then your .pt file is the model you want to use to run the PCA on. So there's a line here as well that you can move your PyTorch model back into Google Drive if you want to. I would probably recommend that you upload all your stuff to Google Drive because the next steps to run PCA, you actually need to provide a download link. So it's probably helpful to just do this. If you only have a very small Google Drive file, you can just upload it and delete it once you've done this process, but it's pretty straightforward. I'll probably record a video later for this if people really want to see like the actual details, but it's like pretty much what you see here. Okay, so once we have a PyTorch model, then we can run the PCA analysis on this. The steps here, which I will go through, are a little like, they're just annoying. You basically have to open up a file directly inside of GANSpace. And a really simple way to edit files inside of Colab is just to double click on them. So we're actually going to edit this file. So we're going to click on wrappers. If you double click it, you'll see that it opens up a little coding window over here. You have to edit 2 lines, and it tells you exactly which 2 lines, and we'll go through that in a minute. You're going to edit these lines. That just says like, so the model inside of GANSpace when we run the PCA analysis is going to know like what files it needs to read from. Once you've done that, actually it looks like this actually uploaded quicker than I expected. Okay, so let's go back and like let's look at what we did within this. So basically we have a bunch of this finished installing a bunch of code. So we're actually ready to like get started. So we're going to skip the convert model weights. So I'm actually going to download or edit in. Let me just pull up my drive here. So I've created a folder in my Google Drive that's just called GANSpace. And inside of here, what I do is I host all of my .pt files. So this is FFHQ. So if you just want FFHQ, just let me know and I can just send this to you. I've got some other models of mine that are here as well. So I'm actually going to work with FFHQ for this demo just because it's a little bit easier, again, to read faces than it is to read some of our more abstract models here. Because of this, we actually don't need to edit that model, that wrappers file, but let me just show you how this would work. So let's say I want to edit this file. So I'm just going to get this shareable link. This is copied. So you want to add your own custom file. What you'll do is you'll go in here and you'll go into the wrappers file and you will double click, and somewhere down here, like fortunately, like Colab is pretty new and it is lacking a lot of features like line numbers. So we're going to just go down here and kind of find what we need. So here's what we need. We need the image widths. So this is for a StyleGAN 2 model. So in here, all you need to do is give it a name. So like I'm going to name mine Floral Mag. And then I need to give it a size, which is 1024. So if you have a 512 or 256 or something else, you'll want to edit this. One thing I should note is GANSpace currently only works with square models. Sid and I are trying to figure out how to actually fix that, but there might be a hack around it. So if you have a non-square model that you want to play with, we can look at how to do that. And I'll know a little bit more this week about how to do that. So you'll edit in the size of your model here. And then there's one more line down here at the bottom, which is for checkpoints. So here you need to actually provide the link to Google Drive to your file. So again, this is going to be Floral Mag. And then you're going to give it a URL. The URL that they give you when you grab a link is not the right one. it gives you the right ID. What you actually need is, once you have this in, you're ready to go here. So this auto saves, you can just hit X. So we now have set this up to be what we want it to be. Next is we actually need to set some PCA options. So what we're going to do here is we're actually going to tell the PCA script what model we want to use, what class we want to use, layers. So layers is a concept of like PCA can pull from any different layer within your network. In my experience, just using the style layer within StyleGAN is probably fine. We do want to use W. So remember, there's two different latent spaces. There's a W space and a Z space. The W space is already going to be less entangled. So for this feature, because we want to like have as little entanglement as possible, we want to use the W layer to get out those features. And then there's a couple of features in here which I generally don't mess with, and we can talk about them if you're really interested in it. But we'll cover some of those things in a second. Did someone post something in the chat? Oh, okay. Caitlin, where do you do that? Is that somewhere in here? Settings? Editor? Show line numbers. There we go. Okay, cool. So that's something I learned today. So you can turn on line numbers inside of the settings here. So then when you go back to wrappers, yep, there you go. You have line numbers. Perfect. Thank you for that. Okay, so as I was saying, like basically what we need to do is we need to set up our settings for running the PCA. So first things you see here are, we're going to use the StyleGAN 2 model. Actually, let's just run this using my custom model just so you can sort of see what happens. It takes like 5 minutes to run this, so it'll be fine. Model class. So the model class is FloralMag. And this is the number of components you want. So remember, those components are sort of ranked in most important order to least important. If you put in 5, I guess you could put in 512. I don't know what would actually happen there, but it's like gonna like basically think about how many components you really want. I would recommend starting with like 20 because 20 is like a small number and it's manageable. The folks that made GANSpace started with 80. The thing is, once you get past, as I've seen, once you get past about 30, it's like kind of hard to tell what is actually happening. It's like very either minor details or other things. And maybe if you have one model you really want to explore in a super deep way, you could turn this number of components up. So you could make it 80, you could make it 50. I'm gonna leave it at 20 just so the demo it'll run a little bit quicker. Do know that the more components you add here, the longer it's gonna take to run, but it's still pretty short overall. So the next thing is I've got a couple notes in here from what Sid set up. I don't recommend running any of these unless you like, this basically tells you what layers are available in your model. But it's pretty, like, I generally haven't found it useful. So I would skip this cell and I jump down to this cell, which is the visualize.py cell. So what this is gonna do is it's actually gonna run the PCA command. This says, here's the model I want, which is StyleGAN 2. Here's the model class, which is the FloralMag. I wanna use the W space. I wanna use the layer style, and the number of components I want are 20. I would probably leave these numbers here as is. So N equals, what is that? 1 million. B equals 10,000, batch. And then what I recommend doing is turning off video. So actually just remove this to start with. Basically this produces all those little videos. The thing is this will like quadruple the amount of time it takes to generate these. I have found that when I leave video on and I have a lot of components, it will take up to 2 hours to generate this. Whereas if I turn video off, it takes 5 to 10 minutes. So I would say like run this for the first time, just sort of see what you get. And then if you really like everything you get, then you can rerun it with the video process. And that's going to generate a bunch of videos for you to download and use. So it's sort of up to you, but like I would definitely recommend that you start without using that. So let's just run this. I should have everything set up, so unless it throws an error, we'll be good to go. This again will take 5 minutes to actually produce. Invalid syntax. Oh, I know what I did there. I forgot to add a comma into my code here. Yep, so at the end here, you need a comma. And we'll save that. And we'll cross it out. Okay, so now I should be able to run this. Dash C expected 1 argument. What did I do here? Well, let's just hard code this in and see if that works. I've actually never seen that error yet. Unknown model. Cool. Let me see if I name my model incorrectly up here. Floral mag. Floral mag. Oh, you know what? I bet I didn't run this cell.
Yeah.
Is that what someone was going to say?
Yeah, I had myself on mute, but I was trying
Okay.
to...
Yeah, so I probably didn't run this cell, right? So you can tell if cells have been run because they should have like a number next to them. And I clearly didn't run this cell. So to save these variables, I actually need to run this cell. So now this is a classic Colab error. Like this is something I do in Colab all the time. So if you do it, don't feel bad. But basically now that I run this cell, now this is stored into the terminal space or whatever you want to call it. So now I can run this and it'll work fine. This is what happens when you're up till 6:30 in the morning trying to get CUDA to run on machines. This is now running. It'll take a couple minutes. I think I see a note here in the chat. Oh, cool. So Caitlin said that she found that layers 70 to 100 did do nice things with color. So I think that is probably true. Like I would guess that like the really late layers are probably more color layers or like really fine-tuned details. So maybe what it's worth to do is like run it for the first time at 20 and just sort of see what you get. And then from there, maybe run it again with 100 components and sort of see how it differs. I also think that some of this depends on how fully trained your model is. So I know some of you that have been hitting like 500K images or like a little bit more are like, might be a little undertrained, and maybe the more training you do, I think the better your later components will be. This is now running. So what we have here now is we have a folder called out. And if we go in here, we can see that there are directions. We go in there, we'll see that is not right yet. So this is still running. Basically what it's doing is it creates a bunch of batches of little points. So again, when it's doing that thing where it's trying to fit the best line of curve, it's sharing all these points and is doing some math here to make sure this all fits into our space. So I think when this finishes running, it'll generate our first sort of component window that we can then download and look at. Well, this is running. Any questions about this so far? All right, so now we are creating our visualizations. So here, now it's created a folder called Floral Mag. If I open this up, you'll see there's a style folder. IPCA, I think, is interactive PCA. I think that's what it stands for. I don't know what the I stands for. And then it builds a couple folders here. So the folder that you sort of want to look at, that I look at generally, is the SUMM folder. That is the summary folder. So if you were to open this file, yeah, and of course, don't open this file in Colab because it doesn't have any zooming features. So let's just download this file. So when I open this, you will see that what we get is a grid of my model, which is this floral model, and then a bunch of sort of components here. So again, the earliest components are going to be big changes. So I don't even know how to describe this first change. Is it like from just leaves to like full flowers, plus some color change? It's like pretty entangled, but it's pretty interesting that you could maybe take a space and then look at just what the flowerless version looks like. C1, I don't even know what that's going to represent. So here's the thing is like with your own like more abstract models, it's going to be harder to determine what some of these big features are. But what is nice is that some of the later features, I think this is what Caitlin was saying as well, is some of your later features will have like some really nice fine grain details. So, you know, looking at C11 through C13, like these are almost entirely just color changes, right? So while the model itself changes a little bit, like the structure of the images themselves change a little bit, it doesn't change nearly as much as what you see, you know, in some of these earlier versions. So in this case, it's like, if I want to go from a pink flower to a purple flower, maybe I want to mess with component 11. If I want to go from a red flower to a white flower, I might want to mess with component 12. So this is just a really helpful way to just sort of like quick high level, sort of see what you're producing, see what analysis the PCA has found. Now, while this is also running, it's also running what's called random images. those random images are literally just like it picks. So whereas the W, if we go back to this image, the W always starts with this. I think this is the 0 space. So I think this is always 0, 0, 0, 0, 0 in the middle here. You have some other options here in Colab that give you different seeds. And I don't know if these seeds are actually correlated to seed 1, seed 2. My guess is they're probably not. But you can still download this and you can look at what happens to a different image. And this is actually really helpful to look at because, you know, just because of the 0 vector or the 0 seed, that just because C11 goes from, what did it go from? It went from like purple to red or something. So C11 here goes from pink to purple, but C11 on this vector, or on this seed, so this middle seed, which is actually changing a little bit. Maybe they actually randomize all of the values here. I don't know, so I've only really explored this in the past week or two. But you'll see here that C11 still changes color and only moderately changes the structure. But instead of it going from over here, instead of it going from pink to purple, it goes from reddish to yellowish. And likewise, so C12 goes from red to a light pink, and the structure changes a little bit. This one goes from orange to yellow, and the structure seems to change like far little. So your input seed does matter. You know, you won't just randomly be able to pick a color and change it from red to pink. It is going to matter what the, like, sort of what's happening already in your image. So that means this stuff isn't like as easy to edit as you might think, right? It's not like opening up a Photoshop script and like selecting a color and then like using the hue saturation slider to change the color. Changing these things will change some of the structure and will change some of the imagery, but it gives you a little bit more of a detail into what you can and cannot change. So this is finished now. So there's some other things in here that are worth looking at. Let's see, refresh. Oh, I guess when you use video, it actually builds out like videos and stuff. So the summary is pretty much everything you need for the moment. So why don't we take a quick break, and when we come back, I'll actually show how to use some of the exploration features here in this notebook. So let's take a break between, let's come back at 23 after. Does that make sense? Cool. All right, see everybody in a minute. So Moise asked if you could save out a seed from GANSpace. I don't think that's something that's set up in this notebook at the moment, but it'd be pretty easy for us to do. So we could add a button, and maybe I'll look at doing that next week or this week. So we're going to explore the interactive features, which are basically like, now that we've loaded these in, can we actually see what each component does with the random seed? Moises, we'll probably just add a thing that'll save out like a .npy file, which will, that way you can then load it in other places. I should mention, I'm adding, so Adam and I were discussing what his project is going to be for the end of the show, or the end of class show and showcase. And he asked if we could be able to load in some .npy files. So basically right now, you know, for most of the features in the manipulation folder, you have to have a seed. But I'm working on adding some features to load in the .npy files. So those files you make out of projection, we can then load those back in and do other things with it. So I'm working on that feature right now. So basically the same thing for this. We can save out a .npy, which will save out the vector, and then we can import that into another, into some other, one of these other models. So we'll work with that in a minute. Let's see, what other questions do we have in the chat? Yeah, so yes, kind of, I'll definitely add that. Ted, can you explain a little bit what you're asking about there?
A question to me?
Yeah.
So you're showing the components, and the later components have more isolated effects. And so I'm wondering if you can find out exactly what elements in the array are the ones being included per component.
Yeah, so similar to other ways, like, so actually I'll run this in the next, in this example, I'll show you, for each component, it will generate a .npy file. That NPY file just contains sort of the changes or the direction of the vector. So basically what we could do is we could print those out and just look at them, and you could sort of see like, oh, it's changing vector 300 a lot, and it's changing a couple of these other vectors a little bit. That's, yeah, so exactly, yep. Cool, okay, so let's actually look at how to do some of this stuff. So basically now what we want to do is we want to explore these directions, right? So we've made We've made 20 components, is that right? Yeah, we've made 20 components. And what we want to do is we want to just explore what each of them does to our different images. So in this section, which is the explore direction section, we're going to now actually need to edit these things. So what I'm going to do here first is, and I realized I don't have this at the moment. I don't have that bird's, actually, I bet I can find it really quickly on my drive. So we just finished our PyTorch version, and now we're going to move back to the TensorFlow StyleGAN version, which is like it's kind of trippy. I know Sid is working on a PyTorch version of everything, which might make things a little bit easier. But for now, what we're going to do is we're going to go back to the TensorFlow version. So again, why didn't that actually? Oh, I know why. So again, because I'm skipping around and didn't run all these cells in order, I'm also missing certain things. So I need to actually run this cell to download the StyleGAN2 folder. So I'm actually going to do this. So that now we actually have a StyleGAN2 over here. And then when you come back down here, you need to make sure that you're saying, hey, where is my StyleGAN2, the TensorFlow version? It's here. So this is the correct path. I need to download my path model. And then the other thing you need to get are what's called the path components. And the path to your components, which are the components you just produced, are inside of GANSpace, and then inside of cache, and then inside components. And you'll see in here, there's one that is already there from just the model itself, which is a big GAN version. I should say that you can also run the PCA stuff on big GAN if you're interested in doing that. I don't think anyone has ever trained their own big GAN model, but if you just want to take the big GAN that already exists, you can do that as well inside of GANSpace. So we're going to grab this one, which is the .npz. I think that means it just contains more than one NPY. But basically, we're going to copy the path here. We're going to paste this in here. And that will give you that'll give us our NPZ files. So what do I want to, oh, I want that floral mag. Shit. This might not actually work because I don't know if I have that file anywhere handy. Talking about where I would have put that. Okay, we may need to rerun all this just on FFHQ. I didn't really think through this demo that well, in part because I don't have, I think the pickle file is sitting on a drive upstairs to actually do this. So let's just run this really quickly again. It'll probably be good practice for everybody to run this directly on FFHQ. So what we're going to do is we're going to come over here and we're going to change our PCA settings here. So instead of StyleGAN2, we're actually just going to run this on FFHQ. Let's keep it at 20 components. Actually, let's move it up to 40. And then we'll save that. And then we'll run this again. This is going to take about 5 minutes to run this. Yeah, so normally I would have all of this stuff set up on my Google Drive, so I could just like quickly save stuff down. But clearly I chose a model that is like the one model I don't have saved into Drive at the moment. So we're going to rerun this again and we'll see how it goes. While we wait, are there any other questions or thoughts about this technique so far?
I was going to save this question for later, but I was wondering about when they're called components. Is that sort of analogous to that line that was like spinning around?
Yes.
Or, yeah, I guess, or is there a paper or something that we can refer to?
Oh yeah, that's a great question. So I did actually add the GANSpace. So inside of our Slack channel, inside the papers channel, which has like maybe me posted like a handful of papers, there is the GANSpace papers there. There's also a really good, oh, you know why I linked to it? I linked to it from here. So the source for this GIF is a link on basically how does PCA work. It's not super math heavy, but it does get in the weeds a little bit. But if you want to understand like sort of what PCA does, this is a good thing to read. I'll say it's still a little math heavy for my taste, but basically like PCA is imagining if you had like any number of vectors and you want to see where the cluster of most of them are, right? So if we've got a space of 512 dimensions and like a lot of stuff is clustered around one area, like that might be the one area we want to pull out. And that's what essentially what PCA does. It pulls out the most salient, like interesting features. And then the reason it starts at 0 is the 0 is the most, is the widest change. And then every component after that is less wide. So basically you take 0 and you try to compute the next widest vector, which is a component. And then as long as it isn't that same vector, then you use that one. And then you find another one and you find another one. So it's like a diminishing returns in terms of like how wide the details are. Yeah, so I recommend like reading through this if you're interested. I generally have, like, there's lots of libraries to do PCA, so I just like use someone else's library and run PCA on stuff. I never have like actually built my own. Let me just check to see how we're doing over here. So let's say we're creating our images, which is great. That means they'll run pretty quickly. In fact, yeah, components are already ready. So we're ready to do this. So let me just do, let me do another thing, which I can't do until this finishes actually, because I really didn't think through this demo all the way. But we're gonna need to download our FFHQ model. So once this is finished loading, or once it's finished running all of those random images, I can then go ahead and do that. So we're at 2, okay, so we got a couple more. Anyone else have other questions while this finishes? Three, hate having to wait for this thing to load so I can finish this demo. Okay, so what we're gonna do here is we're actually gonna load this into, we're gonna load all this detail and data. So we're gonna load in FFHQ. I can start doing this already. Update this so we don't have to do that live. So we're gonna grab our FFHQ. So we load in all of the details about like where our StyleGAN model is, the network pickle we're going to use, where our components are. We're going to load in a little bit of code into here, and then we're going to load in a random component one at a time. So there's 2 ways you can do this. You can load it in at random. I find randomness to be kind of a silly way to explore this, but it's how the notebook was set up. If you want to set up a specific like component that you want to play with, like let's say you want to set up component 0, just uncomment the random line, or comment out the random line and then uncomment this first line. So we can explore individual components one by one. Once this is finished, then we're gonna, you can actually run a little UI here, and there's a fun little feature here of you can change the seeds. So you can see how each of these changes using a different seed. You can play with scale. We'll look at this in a little bit. I personally, I find it's helpful to just quickly go through. But because there's a lag time between you changing this and your image loading, it's like not the best use of a slider feature. It can be a little janky just to like sort of like you move it a little bit and then you wait 5 seconds. You move it a little bit and you wait 5 seconds. You move it a little bit and wait 5 seconds. So there's no like, it's not very seamless in terms of how quickly it runs, which just can make it a little bit frustrating to use this. But I'll show you another way that you can look at doing this stuff. So now that this is finished, let's go ahead and start running this code. So I'm gonna run this, actually I need to download my FFHQ first. So I'm gonna come up here and download FFHQ. Obviously, if you were to do this yourself, you would run through the notebook in the correct order and not have to bounce around. But because I thought I was better than I am, I thought I could do it without it. Now that I've got FFHQ in here, right? So FFHQ is there. I can come down here and I can run, save these variables out, and I can run this, which will load in our model. And of course, because this is the first time I'm running this TensorFlow code, it will need to like run these CUDA processes. So it takes a minute just to do this. While this does this, I'm gonna get our second demo up and running. So Kynan asks, why do people use PyTorch versus TensorFlow? It's sort of like what JavaScript library to use. People just have coders especially just have very strong opinions about what library they use. And also it's like sort of tied to what company you want to support. PyTorch is run through, I believe, Facebook. Although the people that started PyTorch were not at Facebook at the time they started, I don't think, but like now it's a part of the Facebook community. And TensorFlow is Google, so like there's a war there. I've heard it's much easier to learn PyTorch from scratch if you want to. TensorFlow is like a pretty intensive process. So why people use one or the other is any number of reasons why you use any programming language over another. It's just personal choice or what you learned on. They are somewhat interchangeable. Obviously, you can see you can convert models to things, but it still makes it kind of a headache to move stuff around. Okay, so this is loaded in here. So let's load a random component, or let's just like, let's pick, so I think 2 is the profile component, so let's just pick that. Or actually, was it 1? I think it was 1. So these are 0 indexed, so component 0 is going to be that, the gender vector. And then component 1 is that profile vector where it switches people's sides of people's faces. So let's load this in. So if we just hit shift return in this folder, you'll see it says loaded component 1. Then you can run the UI. So just press the little button here. There we go. So we have a person at a seed of 39,355. Distance. So distance is essentially, if you remember that the graph we saw at -2 was on the left, +2 on the right. So what I should get is that at -2, it should be the person's face turned to one direction, at +2 is the other direction. So let's try this out. So we can go in here and we can just type in numbers. Let's do -2.0, hit return. And you'll see the person's face turned a little bit, but not too much. And then again, if we do +2, so we're seeing it's much strongly. I've found like with this particular component, it's much more strongly to the positive direction than it is to the negative direction. So what we have to do is do negative. Let's try -4. So, all right. So like apparently we can't get this person's face to the full profile. You can kind of see them start to switch a little bit. So again, if you like, the slider here is like a little rough, right? Because like if I move the slider, it takes a little bit of time to upload or update. It's like not terribly slow, but it's also like not really great. So this works. So what I would do is if I didn't know this was the profile vector, I might like play with these a little bit, right? So maybe I also want to change my seed. And then play with the directions again. That's interesting. So yeah, so this sort of tells me like, okay, now I know that this is definitely the profile vector because it happens across any number of seeds, right? If I pick any seed, I can sort of like change their face direction. Okay, so this this UI also comes with a thing that where you can name your component. So what you can do is you can just type in here, you can type in profile and then hit return. And what you'll see is latent direction saved as profile.npy, profile1. So if you come into, I believe, the StyleGAN folder, you'll see here that there is now a file called profile.npy. And to Ted's question, let's actually look at what that looks like. So let's do print, and then we do np.load, and then we're going to copy in this path. Maybe this needs... There we go. So here is what this vector actually looks like. And obviously you can't see all of it because it's, I forget exactly how you do this with print, how to get the entire collapsed network. But basically you could see that there are any number of vectors that are changing a little bit in here. So this is basically a way to look at this. I think, yeah, let's see. Does anyone in the chat know how to do this? Okay. Not yet, but that's fine. Anyway, you could save this down. You could also like save it as a text file or whatever and actually look at it deeply. One thing to note about this is that these are in WSpace. So WSpace is, yeah, so WSpace is actually 18 components or 18 different arrays of 512 dimensions. So this is a pretty, the WSpace is much larger than the ZSpace. So that's probably why it didn't output very cleanly, because you'd have to output millions of numbers here. But you could like just save this to a text file and then look at it. Yeah, so basically this gets into NumPy. If you, learning NumPy is like probably the next most important thing in terms of StyleGAN. So if you are a coder and you want to learn something, NumPy is the way to go, because pretty much everything is done in NumPy. I won't talk about that here because it's not anyone's favorite world. So okay, so now that I've saved this vector, I can actually do a thing here, which is I can actually generate a video directly from that name vector. So remember that I saved this, I saved it as profile.npy. It saved an npy file for me. And now I can actually generate a video from this. So let's just say I want to generate a profile video. So this is just the directions name. So it's just the name of the file. This will save out the location, which is going to be, it's going to be actually like component 1. And the number of samples, I'm going to make this really small so we don't spend all day generating videos here. But basically, we're going to generate a video from this. So what this is going to do is it's going to generate it's going to start at a random point. If you wanted to generate a seed from a specific point, I think you could do that by just generating, like, let's say 0. I think if I put in 0, I think this will work, so it doesn't break. And then we're just going to generate a movie from it. So let's just try this. This is generating all my frames. I should say you can also edit the frame count. So actually, let's do this here. Let's say frame count equals 50. So by default, it's going to be frame count equals 50. And then we'll just paste that in there. So if you want more than, I don't know, it's a pretty short video. If you want like a very, like, this is a very quick video, probably like a couple of seconds. So this saved it. Where did it save it to? To out. Here we go. So if I download this, and let me open this in Finder. Okay, that is not seed 0, but that's fine. So here you'll see we've generated a video, which shows it shifting from side to side. Now you will see as we get really toward these edges, it gets pretty murky. And that is this, there is a distance function in here, right? So there is a, it's not in this. So I use, so we'll talk about this when we get to the audio detection, which is, there's a range that this goes from. So on the, all the way on the right in these is -10 to +10. So you'll see like, or sorry, +10 is like probably like this. So you'll see as it gets toward these really far edges, it gets pretty gnarly, right? So like this one looks fine, but like this one looks pretty messy. So you can change that range, not in this video, but in like some of the other libraries or some of the other code I have. This just helps you sort of see like a visualization of what this looks like. So you could run this on multiple different pieces. You could run this on, you could change out your seeds. I'm actually just gonna add this to be, shit. Okay, copy this, and then go back. I'm gonna make that random again so that people can generate more than one image. And then we want that to be frame count. So that just generates videos. It's pretty straightforward. If you want to just like create quick little visualizations of things. There's also some code here that allows you to then like do this again, but only with named vectors. I didn't find it to be super helpful. And then you can, of course, and what I recommend doing is actually downloading these MPYs. So you can either save them to Colab or you can download them. I'm going to download this one just so I can use it in the next demo. Okay, so before I jump to audio-reactive demos, are there any questions about this? Thank you, Caitlin. So Caitlin provided some code. I will add this to the notebook after class to basically print out all of the vector completely. Moises, your question is, so these are vectors you're pulling from the component PCA. What is the difference between these sliders and the video sliders? Oh, nothing. Those video sliders are literally the same thing. It's just like that was, because we, in order to run GANSpace, the other repo, like you actually need to have it on a server. With access to HTTP with like a URL. All this does is it replaces that. So instead of having the sliders that let you look at every component one by one, this you have to pick an individual component and then run these sliders. So the distance is actually that component you're seeing everyone play with in that GANSpace video. And all they're doing is they're combining this with the component. So SID's library just gives you more features to play with, but it's pretty much the same thing. Okay, so let's look at some video stuff. So or some audio stuff. So I'm gonna unplug here. Hey, now can you hear me? Great, okay. So similar to last week, we're gonna look at how to actually embed, like how to generate this with video. So what we're gonna do is we're gonna actually do this thing. Let me just hit present here. Make sure my audio is on. So literally same demo as last week, except all we're going to do is we're going to take that profile feature vector and we're going to use that to change the direction based on sound. And this is where I described, so inside of my code, there is a thing to control what we call range. So this is a range of 2. So you see like, you didn't get those like very like digitally bit crunchy sort of edges. But then there's also one, this is the range, this is the default range that they use for those video generations. So if you want to get really like weird and creepy, there's some stuff out here that is called range 10. So let's look at how to do this. So inside of this notebook, go ahead and open this in Colab. So this is pretty much the exact same thing we saw last week. All I did is I actually added another section at the very end of the notebook to do audio-reactive stuff. But because this is like sort of starting, we have to sort of start from scratch. So let's just load all this stuff in. Let's download FFHQ. Man, I really thought I was going to get this to under an hour and a half today. It's not going to happen. Okay, now we're going to upload an audio file. And then like last week, we're going to process this audio. So we're just going to hit shift return for these 2 variables, and then we're going to run the audio process. Cool. So this generates our images, or an image of just the audio, like a spectral analysis of the audio. So this is what that sound looks like. I'm going to run this, although I don't know if I need to, but let's, so this is some code just to generate these vectors. And then we're going to skip the volume generation. We're going to, yeah, so we'll skip these 2. These are the ones I demoed last week. And let's look at feature vectors. So how does this work? So the first thing is that we are loading in some code. So the first thing you do is make sure you set your network pickle correctly. Yep. This is just going to load the model in. There we go. Oh, there we go, finished. Okay, so we've now loaded in our FFHQ model. Now the next thing is we want to just run this video. We want to create a video that uses our that profile.mpy. So what I want to do is I'm actually just going to upload that file I downloaded. So this is the NPY file, right? So this is the feature vector that we were using. So you want to make sure it's referenced correctly. I noticed I changed the name previously. So this is now referencing that file. You have a truncation value for generating just any, this is for any FFH or any StyleGAN 2 model. You have a seed. So the seed is going to be your image that is at your middle point. So anytime you've got a 0.5 of volume, this will be the seed that shows up. So it's important to remember that, like, yes, this does matter, but it will not be your starting or end point. So whereas in previous versions, we have one where we're lerping over, or we're linearly interpolating between 2 seeds. This one, we are only starting with a middle seed, and then we are using our vector, our feature vector of the profile to manipulate the sides, right? So at 0, we're going to actually get that sort of one direction where it's facing this way. And at +1 of the sound, we're going to get the other side of that person's face. And it's not really the same person because all this stuff's entangled. So this is the profile view. I think all you need to change are these couple lines, and then it should just run fine from here. So the feature range, so again, this is that, do I want it to be like really like crunchy at the ends, or do I want it to be like pretty smooth and all human looking? So you might want to make this smaller or bigger. I would say 10 is probably the max unless you want to get really crazy. I mean, let's just do it and see what happens. But also you should know that like, if you want like a really smooth animation, you probably want to be making this number small, because basically it's maximizing. If you make this really large, it's going to really quickly jump between things. It's going to feel really fast because you're only mapping it from 0 to 1. So it's going it's going to -20 to 20 rather than like 0 to 1. So just make sure that you're aware that like speed kind of plays into a factor here. And then scale is something that I don't really play with too much. Basically it multiplies this times this. So I don't know why you just wouldn't set the range higher, but for whatever reason it exists in case you're interested in it. This will just run if you're interested in the code. The main thing to look at here is that actually all you're doing when you are making this image is all you're taking the so you're taking the audio signal in, and you're like basically mapping this to the min range and max range. So it's again -20 to 20, and you're taking in your signal, and then you are adding that signal, that feature vector, times the scale to your W. That's all it is. So it's just a mathematic operation. So when we run this, we're actually going to generate we're going to generate this video. RND is not defined, of course, because it didn't run one of these lines of code up here. Probably this one. Is that right? That seems wrong. Somewhere in here, I didn't import random. There we go. Okay, so that's something helpful for me to know is that I need to run this again. So let's do this. Hey, I'm definitely defining random here. What's going on? Okay, so let's try this again. Oh, probably referencing this before I actually run it. So let's move this up. Sorry. Once again, Colab strikes me. Let's try that. There we go. Okay. So we're just going to run out each one of these frames, and we're going to convert it to a video, and then we're going to add the sound back to that video. Oh boy, for real? LARP is not defined. Okay. Clearly, I need to demo these better. Where am I defining my LARP function?
I think I saw it in the generate images cell.
Perfect, thank you. All right, so let's take that down here and let's find that here. There we go, okay. All right, so while this outputs, any questions?
I had a quick question on projection. Does the Colab notebook for projection, does that support using a different a model that's 512 by 512? I saw that there were some errors when I did that, and I didn't know if it just doesn't support it at all. Or...
I noticed Octavian said the same thing. I'll have to take a look at it. I didn't get a chance this week to really take a closer look at it. My assumption is there's probably some way to do it, but I'll also have to look. There's probably a place where it's converting because it's running through that inception network. Is it inception? I think it's inception that uses to create the loss function. My guess is that there's some place where it's converting to the right sizes and maybe it's converting back to the wrong size or something. There's probably something that we can fix.
Okay.
But yeah, it might not work for right now, but I'll figure it out. Yeah.
Okay, yeah, there was an assertion in there that makes sure that that two different shapes were the same size.
Okay.
And I just kind of didn't look at it much further than that.
Yeah, I'll take a look at it. That's a good note. I'm gonna make a note for myself in our chat just to make sure I take a look at that.
Okay. Thank you.
Yep. While this renders out, I also want to make a note that I think I've talked about this before, but since most of you are probably finishing up your models, there is a guy on both Twitter and GitHub that has a awesome pre-trained StyleGAN 2 folder. I would recommend that if you're interested in sharing your file, so you'll see actually maybe you don't know, this is one of my models here I shared with him from my runway class. But if you're interested in sharing your model with the larger community, you can, there's a form here at the bottom to share your file with them. Justin will basically put it up and then people can use your file. These are probably really helpful for a lot of machine learning data scientists to basically have a wider range of things to work with. It's totally optional if you want to share your model. I believe owning your model is a thing you should own because like you spend a lot of work to build that data set for it. But if you are interested in sharing this with the larger community, you can send Justin a note and have your model uploaded. And it'll be really helpful for folks in my classes, and then also like definitely for other people in other classes, like across the community. So if you are interested, you can just like go to this URL and then there's a form at the bottom, or there's like a file you can submit changes to. So pretty cool. I definitely recommend that if you are interested in sharing your model that you do, because it's gonna be really, really big for the community. All right, we're almost finished here with sharing these frames. I think we're done. So I'm gonna generate this to make sure I got my folder right. Paste in my folder, generate a video with this. Let's say range 20. And then we're going to recombine the audio back into this video. All right. Let's download this and take a look. So there you see, this is what -20 looks like. It's pretty gnarly and pretty crunchy, but also kind of cool. So depending on what the effect you want to get, you can get some pretty abstract effects with this. But you will see this feels way faster, right? Like the jumps in these steps is like really, really fast. So that's audio generation using those vectors. So again, whatever vector you want to use, you can just upload it to Colab, and then all you need to do is reference it in this file here. Whoops, the right file? Yep, the right file. So right here. And then it should just run from there. Okay, so that covers everything that we're going to cover in this class in terms of demos and other things. I do have a little bit left, which is just I want to talk a little bit about where else you can learn things. Before I jump to this, any last questions about feature vectors? I will take silence. Oh, Adam, go for it.
Sorry, earlier on, excuse me, the previous demos, I think this might have been what Moses was asking about. What the UI I've seen in the other demos has like multiple sliders. Is that something that like is possible, or is that something that like is kind of cheated for for that little video that they have on the GitHub page?
Yeah, so that is there. So basically, if you set up GANSpace, not in Colab, but like on a server, like say on, I think probably like on a Paperspace server, they have an interactive widget viewer where it allows you to do stuff like that. So you could combine those vectors together. Like because these are just vectors and they're math, combining a little bit of one and a little bit of another is totally a thing you could do. The UI in that Colab notebook doesn't support it, but you could feasibly like add multiple feature vectors together. So say you want like the profile plus the hair color vector, like you could do both those together. And that's sort of what that, I think that's what Moise, yeah, I think that is what Moise is talking about. You can do that stuff. It's just this Colab notebook doesn't really support it because it's not really, the GUI for Colab is a little gnarly. But if you want to set up GANSpace on like a local, on like a Paperspace server or something else, you definitely could do that. You just need the address to be able to actually like pull it up. And that tends to be, I think GCP finding like a static IP address setup is kind of annoying through it, but it's possible, yeah.
Okay, I might just do a recording and cheat it kind of thing and put it together or something. Yeah, got it.
Okay, if there's no more questions, I'll jump to sort of some other places to keep learning. If you're interested, like obviously first thing first, you should continue to use our Slack channel, either the StyleGAN 2 channel or any of the other channels in my Slack. We've got a new like sort of share projects channel. If you're really interested in sharing your work, I think that'd be a great place to start. There's also a StyleGAN channel, so share stuff there. You're also welcome to keep sharing in the StyleGAN 2 deep dive. You know, just I would expect the amount of people to respond in there like will be slower or whatever, but you're also welcome to share whatever. I hope you've enjoyed this class. This is definitely the most advanced class that I've taught. Like I literally like for the past 2 weeks, I've been learning this stuff that I've been teaching you the week before I teach it. So like, this is definitely like bleeding edge stuff. I haven't seen many people do anything with GANSpace yet. So I'm really interested to see what you guys do. I do have a couple other courses, like Leah and I just finished up what is called this Runway Deep Dive course. If you found setting up a server or like anything dealing with code to be really, really annoying, I recommend checking out this Runway class. So Runway is a GUI, like it's a desktop app and a web app that you can learn to use Runway. You can do StyleGAN training in there. It's just a little bit more limited than what we did in this class. But you can do it. You can also download your pickles and still bring them into Colab and things. So basically this is like the basics ML art class that we teach now. It also explores a wider breadth of models. So if you're interested in other things, I know Moises and Fabiola have been in this class. So they're taking both these classes at the same time. So if you have questions about those classes, you can hit up those too. Leah and I also earlier this winter taught what is called the AI 2.1 class. The artificial images middle class, which is like the class that I've really been teaching for the past year. Goes a little bit in training. It uses Paperspace, but we look at pix-to-pix, StyleGAN, style transfer. So this is like a little bit wider. This is like sort of if I called Runway the basics class, like AI 2.1 is the middle class, then StyleGAN is the advanced class. So you're welcome to check out his videos. You will get different things. I would say in general, like this class probably covers like maybe 25% of the material in this class was also covered in this class. So we have a little bit of overlap. The videos, these are all YouTube videos, like they're full class lectures. So you're welcome to check those out. Leah and I are probably gonna be doing some other classes this spring, or we're in the summer now, right? Like it's crazy. Anyway, we'll be doing some new classes probably starting in about a month. So I'm not sure what we're gonna teach yet. We're still sort of working out the details. I am teaching another Runway ML class through a studio here in New York called SSHH. That's already sold out, so unfortunately no one else can sign up for it. But Lee and I will be announcing whatever new class we're going to teach in the next, probably next couple weeks. We're going to figure out the schedule over the next week or two. If there are things you're really interested in learning, let Leah or I know. There's also a survey we're gonna like shout out at the end of course. So let us know in the comments like what you found helpful with this class, what you didn't. And we will try to like coordinate things as people request. Obviously, these are pretty small class sizes. So if like 5 of you ask for a certain thing, like I will generally consider like that a good idea to teach that class, because there are 5 of you, like all I need to do is find like a handful of other people to actually teach a full class. So definitely let me know what you're interested in. In the cases of things where I'm not familiar with it, I might just suggest you to other people, or I don't know, maybe I'll find another instructor to teach these courses. We'll see. But we're really interested in hearing your feedback. Okay, there are other ML art channels if you're interested. Runway has a bunch of videos. These are all specific to Runway, but they're helpful if you're interested in just sort of playing around. Gene Kogan does a lot of videos around like how each model works. So he's done a lot on GANs, and then he just started a series recently on GPT, which is text training. Gene also has a course called ML for Art that I was taught at ITP about a year ago. He goes way wider than I do, but there's less demos. So he'll like, it's a lot of lectures. He'll show a lot of work. He'll show a lot of various things. But I definitely recommend checking that out. Gene's great, really good at understanding certain things. Dan Schiffman runs a YouTube channel called Coding Train. It's like a general generative art class, but he has a bunch of stuff on machine learning. So it's machine learning. ITP has a program called ML5. Is that right? Yeah, I think it's called ML5. That is like a JavaScript version of machine learning. It can't go nearly as deep as we do, but it does do some interesting things. He has a bunch of videos on different parts of machine learning. So if you're interested in sort of like maybe more basics underlining what happens in machine learning, those are a good series to watch. If you're interested in just learning more about machine learning overall, these are my recommendations. So Fast AI is an online course taught by Jeremy Howard and Rachel. I'm blanking on Rachel's last name. But anyway, it is like, I have sort of set up these courses based on how they work. So they work on a lot of demos, like they give you a notebook and you just start working through them. They explore a lot of different ranges of machine learning, and Jeremy's a pretty good instructor and will teach you a lot about like how, like the innards of machine learning. So I'd probably recommend that first. The MIT Deep Learning course is run by MIT. It is mostly lectures, so there's no like code or demos or anything. It's mostly exploration of how machine learning is moving, but it's a really good course. There's lots of different material in there that might get you interested in other aspects beyond StyleGAN. Andrew Ng's Coursera course is probably like the most popular machine learning course in the world. I think there's like millions of people sign up for it. It's good. It's definitely good. There's like a lot of work. It is very like machine learning code focused, but it's helpful if you're interested. And if you're not a video person, I really recommend Francois Chalot's Deep Learning of Python. It is a very accessible book. Francois is also the creator of Keras, which some of you might have heard of. Keras is like a framework that sits above I want to say JavaScript. Sits above PyTorch and TensorFlow. So he's just really good at abstracting away some concepts, and there's a lot of good code in there. And again, he goes wider than anything I teach. So he'll cover GANs, but he also covers different types of machine learning networks. So as I mentioned, please keep using our Slack channel. Runway also has a Slack channel. Runway's Slack channel will be pretty much specifically focused to their app, but there is other content in there related to machine learning. Like maybe there's new models out that you might want to explore. So it's a good place to just sort of keep an eye on what people are making. There's lots of good like shared out resources. There's a creative AI newsletter run by Luba Elliott. It's definitely cool. Leah is a big fan of it. Yeah, it's like pretty helpful. Leah, do you want to add anything to that?
Oh, she sends out like update digest of like everything that's happened in like the ML creative world, like every 2 or 3 months, and it just like contains like I don't know, probably like 20 or 30 different links and short little like 1 sentence like Rafik Anadol has this exhibit here and then a link to it, and it's really great for just like getting an idea of like what's happening right now.
Yep. All right, so if you are a Twitter user, these are the people I can recommend to you. I have a list of coders and artists, and the truth is like these lines are very blurry, right? Like Gene writes a lot of code, and then someone like Doran or Sid also make art. So like, don't think of these as like specifically one or the other. It's a little bit of everything. these are folks that I follow on Twitter for StyleGAN stuff because they're very helpful. Guys like Sid, guys like Peter are basically like also posting a lot of their code and samples. So a lot of stuff that you've learned in this class, like today was almost entirely stuff that Sid helped write. We actually didn't end up covering Peter Bailey's StyleGAN model, in part just because the data set up for it is like pretty intense. But if you are interested in this, I can let you know how it works. Chris runs Runway, so he's just a generally like good person to know inside of machine learning. Sean Presser runs a Discord that is all machine learning. If you want to get really deep into GANs, this Discord that Sean runs is like pretty amazing. I think I've linked to it before in the past. And then artists, so Gene obviously is a teacher and an artist. Mario Klingemann is like pretty much like hands down like one of the people that everyone knows in machine learning art. Robert Luxemburg, so his Sonic, the audio-reactive stuff, a lot of my code from last week came from him. Kisha Yuma is just a really great Japanese artist who does a lot with video in StyleGAN. Sophia Crespo is an artist that does a lot with biology. And then they also take the bits that they produce in StyleGAN and then collage them into really interesting pieces. Rafiq Anadol is an artist who does like big, massive scale StyleGAN stuff. You've probably seen his work on the internet. And Tom White his name is Dribnet on Twitter. He also has a lot of, like, he's got a lot of really cool resources. He's written some papers on exploring imagery in GANs. I don't think he posts as much on Twitter these days, but he's sort of an interesting person to follow anyway. When he links to stuff, I'm always really interested in it. Obviously, Luba Elliott, who's a curator. And then Leah, you added some ML music people who I'm not an ML music person, so I don't know much about the space, but maybe Leah does.
Yeah, I also don't know too much with the space, but the first two people are from Google Magenta, which is like Google's like creative AI thing. They do mostly like ML generated music. And then now Tokui, he's a Japanese DJ who like makes generated music. Just some like little tasters to explore and learn too.
Yeah, and I think the OpenAI community just released some new thing called Jukebox, which is like, it's almost like a GAN for audio. It's pretty interesting. I'll link to it in the inspiration channel. I am like, in music generation and text generation for machine learning, I have like very little knowledge. So I'm happy to send you to other people's way, but I unfortunately have like very little knowledge myself. Cool, so that's it for the class. I hope everyone really enjoyed it. Leah and I have a survey up. Please fill it out, like, no matter what, like, yes, but if you hated the class, I would love to know why. Because Leah and I are always trying to like tweak our class schedules. So actually, like, the reason this class exists is based on survey from other folks. Basically, I was teaching that middle ground AI class. And then I sort of heard from certain people, like, I need something more basic than this. And I heard from other people, like, I need something more advanced than this. So we ended up splitting out that class essentially into two classes. So now there's Runway class and there's a StyleGAN class. So I do take your survey like feedback very, like, I take it very seriously. And I think we heard from previous classes is like, we were just dumping notes in Slack and it felt very chaotic for people. So we built up that class page. So hopefully people have like a single point of truth for resources. So like your survey like stuff does help us like make these classes better. So hopefully every class we teach will be better. You can also in there say, I want to learn about this. Like, it would be great if you could teach me more about this. So like, we will definitely be trying to take this feedback and like building from it. I will also say that I have a Patreon. Like, obviously you've paid for this class. Like, I don't need any more money from you guys, but if you are interested, I have a Patreon where even for like $1 a month, you will get discounts to any of my classes. So I think if you give me $1 a month, you get like 10% off classes. So when we release the next list of classes, like my Patreon backers get first access to those. So some of our classes sell out quickly and like you want to be the first one to make sure you get it. You can sign up through there and you'll get like basic early access like a couple days before I release to the public. And you'll get discounts on classes as well as anything in my store. So if you're interested, check that out. But yeah, and also like I take feedback through Patreon pretty seriously as well. So you can always give me feedback, either survey, Patreon, DM me in Slack. I'm happy to sort of like try to help with where I can with things. And then lastly, like your assignments are just like finish thinking about what you're going to finish up for the workshop. And as I mentioned earlier, like I don't think you need to present like a perfectly pristine final project. Like if you struggled through certain things or like found something new that you thought was interesting, like that's enough to present. Like, as I've said before, like so many people are not even yet at the stage that you're at. And I think they would all love to hear what you're working on or what you learned, right? I have definitely struggled through much of this content to help you guys out as much as I can. And I think it's like a pay it forward thing, right? Like you learned a little bit, like pay it forward to the next person. I know Adam's doing some writing that's going to be really interesting for some folks in his world. I am not a blogger or like I don't write a lot, but like the way I share stuff is through my YouTube channel or here. But like if you are more into writing, I would love to like retweet or post whatever you write about this class. I don't care if it was negative or not. Like I just, I think there's so little information about a lot of this stuff out there in the world that anyone sharing anything is valuable. So don't think that like, oh, I've only spent 5 weeks in StyleGAN. I don't have anything to contribute to the community. I guarantee you do. And it's all worth sharing. So hopefully you can share either through this or over the internet or whatever. But this will be like super low pressure. Like no one's going to judge you for how you talk or like how you present your work. Like just show some stuff. It's going to be fun. We'll figure out a way to do like digital clapping over Zoom or YouTube or whatever. So please like feel free to sign up for a slot. There's no pressure if you don't want to. But I think it'll be fun just to show our work to like a bigger group of people. Leah, do you have anything else to add?
Just included some links to the 2 classes taught at Anderson Ranch this summer. Allison Parrish's poetry ML class, and then Jean Togan's also teaching a class.
Yeah, and so I've gone to Anderson Ranch the past 3 or 4 years in a row. It's a beautiful space in Aspen. It's basically like a little art vacation. Obviously this year they're not doing stuff IRL in Aspen, but they're going to do their classes over Zoom, and they've discounted the prices for those classes. So I think that'd be pretty cool. Even if you're not interested in ML, there's some other digital artists who are also doing classes there. I think Adam Ferris is teaching a class there, and some other folks are as well. So there's 2 ML classes. Jean's teaching one, and Allison is teaching one that are definitely worth checking out. But yeah, I think it'd be definitely worth like checking those out because they'll be pretty cool classes. All right, so with that, we are finished up with the class. I just want to say again, thank you so much for all of your effort over the past 5 weeks. I want to remind you, this is not easy stuff. Like, this is hard for many people. So if you struggle through certain part of it, decide you hate yourself for certain parts of it, I am definitely there with you. Like I said, I was up till 6:30 last night trying to install CUDA. So like, I am right there with you in that this is a struggle and this is hard stuff. And during anything that looks cool is like a huge feat. I don't care if you got one good image out of this class, like that is a huge feat. And you should be proud of yourself. And I hope you'll continue learning with this. I know that also for some people, they're like, never want to touch this again. And that is also something to learn. So it's good to learn that as well. But I hope you enjoy this class. And again, like feedback to me or Leah is also very, very helpful. So I'll hang out for another like 30 minutes and just take some Q&A on either stuff you're struggling with or just things you want to work on or whatever. But otherwise, you're welcome to like head out, and hopefully we'll see you in 2 weeks for the showcase. Again, you're welcome to just be a participant and like a watcher. You don't have to present anything if you just want to come hang out and see what other people are making. And if not, I hope to see you at least in the Slack channel over the next year or so. So thanks again.
Thank you very much for this. It was awesome.
Cool, glad to hear it.
Did you ever get your machine posting when you got it back in the case?
I did, yeah, it posted, yeah.
Okay.
So I think it was, Octavian isn't here, but I think it was actually because of the, I was running a second GPU, so, or another GPU that I don't think is supported by my BIOS, so I have to fix some stuff with that. But yeah, that was what the issue was.
Okay, cool.
Yeah, thank you so much, Derek and Leah. All of the like documentation and notebooks are like, I feel like I'm going to keep coming back to those and like generating cool stuff. They're great resources.
Awesome. I also want to say, like, I have a big shout out for Leah. Like, I am like not good at taking notes. I am not good at documenting my work. So Leah's notes week to week, if you haven't looked at those yet, they're really awesome. And they are definitely a great resource. So thank you, Leah, for taking all your notes.
Thank you.
Thanks, Derek and Leah. This was a great class.
Yeah. Does anyone have questions about their work or like want to talk about anything? Happy to hang out for a little bit.
I had a general question about GANSpace. Like, what do you want to play with it? Like, what do you want to make with it? What potential things do you think would be cool to use it for?
Yeah, I mean, I'm really interested in exploring some of the feature vectors. I think there's a lot of stuff in there, like especially with custom models. So a lot of people, you know, in the GAN community have really explored how StyleGAN, how the FFHQ model works, right? Like everyone has FFHQ demos. People have explored sort of like, what does the open mouth look like? What does the profile view look like? How do we change genders? How do we change skin color? Which, oh God, there's so many ethical questions I have around like gender and skin color changes, but like that's a whole other class. But like, I cringe when I sort of see people being like, I want to change this person from white to black. It's like, oof, geez, okay. But anyway, so many people have done stuff with FFHQ, and it's like, I don't want to say it's a dead space, or just say there's been a lot of effort only explored in FFHQ. And I'm really interested in how GANSpace in 10 minutes can help you explore your own custom model way more than you could doing it manually, right? Like I know a lot of you have been like, hey, how do I generate more seeds? Or how do I see what's really in this model? And I think GANSpace is another tool. Like all of these, there's no one perfect tool for all this stuff, but all of these things are like little pieces to like build into a toolkit that can let you do any number of things, right? So now that you've got feature vectors, in addition to interpolating between seeds, in addition to projection, like you could take projection, like any of these things can be added together to create new things. So I'm just really interested in like, again, GANSpace in 10 minutes can show you new things about your model you didn't know existed. Like for me personally, like seeing that floral model and seeing that like I could really change colors without really changing too much of my flower structure. Like that's huge. Like that is, again, that's like a Photoshop capability, but it's like built into a machine learning model, right? There's any number of interesting things to play with now. And I think like, you know, I focus a lot of my time on training new models, but like I'm also seeing now that there's like so much more opportunity to explore like an individual model and spend like, you could spend a year on an individual model and still not learn everything that's in it or like how it all works, you know? So I'm just interested in new tools to like let us explore those features. Martin, go for it.
That just made me think about, I was kind of thinking about what, like, if you had any, I don't know if you have any inside knowledge, but of any, like, what do you think, like, the next, like, tech or, like, the next advancement, like, do you think that we'll just get more and more tools to, like, explore models more and more in more fine-grained detail and more to utilize them more in more ways before you see like a StyleGAN 3? Like, do you think that's like more likely to go down that route of like being able to like explore that more before it's like, and we do it for like 20 by 48 pixels or whatever?
Yeah, no, that's a great question. I mean, I think every one of these sort of machine learning data scientists is working in different spaces, right? So that Discord that I talked about with Sean Presser, him and this guy called Gwern, who some of you might know from like, he's written some really great long posts on StyleGAN and other machine learning topics. The two of them are working on building Big GAN on top of a thing called TPU, which is unlike a GPU, it's like a purely for TensorFlow. It's like some big, huge Google server project. They're trying to figure out how to build Big GAN at scale to work on these models. So like there is a team that is looking to scale up production, like how do we feed it more data? How do we like make it train faster? Like all these sort of things. So there's a group like that. There's a group of, you know, sort of the people who are like GANSpace, where it's like they're exploring what are the tools inside of there, right? And one thing you'll notice is the GANSpace folks, I believe, work at Adobe Research, right? So clearly Adobe would be interested in this, right? Because what if I can bring these tools into Photoshop? You can give me a photo of someone. Behind the scenes, we can run a projection into that. And then we can edit someone's face using just machine learning tools, right? So like, clearly they're really interested in this. A company like NVIDIA, which makes graphics cards as well as a bunch of graphics cards tools, are interested in this because they basically want to keep gaming studios using NVIDIA servers or NVIDIA graphics cards. So they're trying to generate tools for, you know, gaming users, like, and the gaming users have their own needs or whatever it is. So all these groups are like looking at different things, and like that can only be good for us. The problem is that like no one is sort of centralizing these things, right? So like I found GANSpace like a week before class started, And I've only seen a couple of people use it since because it just didn't get the traction it did. One of the reasons that StyleGAN is as popular, like for whatever reason, StyleGAN is more popular than other models because it built a community up around it. Part of that might just be there was NVIDIA and they like produced a lot of good content to like basically prop it up. Part of it is just like, it was accessible, it was, like you download it, you can play with it, that sort of thing. Whereas something like BigGAN, so BigGAN was done by Google. Google didn't release the source code for it. Actually, the intern who wrote the project rebuilt it in PyTorch and posted the code for that, but it's not the official Google version. So like there's all these like little bits and pieces and corners of the internet where people are working on this stuff. And I'd say like the community is very supportive, but it's not like connected in a way that is very clear or very helpful. So much stuff could go in one direction. The other thing is like people, like maybe some random person out there who works at some lab is going to create something that is higher resolution, better disentanglement, better things. And like everyone will just like automatically gravitate toward that or not, who knows? It's like so hard to say, but I feel like there's lots of like pockets and I see lots of directions of where people are going with things. Esteban.
Thank you, Derek. Thank you, Leah. I think the course was fantastic. It's my second time with you, first time with Leah, and I learned definitely. I learned a lot.
Cool.
And thanks for your support and patience with my questions and stuff. I have a question for both of you. What's your view about the art world regarding this machine learning stuff? Because I see that, I mean, it's going to change everything. In my case, specifically, it changed my view completely about how to generate art and how to view art. And I've been talking with some friends about these things that I've been creating. And now I see that I can create 20,000 pieces of art in 1 minute. I mean, it's going to change everything, I think. So I wanted to know what's your view about this.
I'm gonna give that one to Leah first.
I think it's kind of similar to, I don't know, this ongoing discussion in art of like, is this considered art, especially when technology is involved and like the question of ownership. Like these are not, like you're training on data sets that a lot of the time are not your own work. And yeah, I think it's interesting, that question of ownership. And it's a very, very, very different process of making like generated GAN art than like making your own artwork by hand. And yeah, I think within the art world, I'm not too sure what the art world thinks. Do you have a better idea of that, Derek? Of like where GAN art fits within like high art world?
I mean, I think, so the art world, like we can talk about like the high art world of like galleries and that sort of thing, or we can talk about the like middle space, which is like, there are a lot of these art galleries opening that are really just like Instagram factories. Like every one of these layers has a different appreciation or a different viewpoint on ML art. I don't know. It's like, I could probably like rant myself blue in the face about like all these different areas. My personal experience is like, I can't care about what other people think about the work. Like I can only think about what I think about it. And like, I think it's a really interesting place to explore things. I sort of approach the work from like a slightly different perspective. So like I have been, maybe for the past 6 months or a while, like, you know, just like how, I think this is about how machines see, or like just about like, how do we change how we see, right? Like, or how do we like combine those two? I've been a big fan of like Stan Brackage's work for a while, and Stan Brackage's work was all about like sort of what he called the untrained eye, which is like, how do you like remove all the shit you've learned about what art is supposed to be or what other things are supposed to look like for a long time, and then how do you bring it back to like, just like his idea was almost like, if you close your eyes, you still see things through your eyelids, and how do we represent those things? And I think like that to me is what like a lot of this early machine learning work feels like. I think we're also in a really interesting time for machine learning right now, because it's like, and I've said this in other classes, but it's bad. It's like, it doesn't do what it's supposed to do. And like, I think that's a thing that's worth exploring, or a thing worth exploiting. But at some point, it probably will be good enough to do what it promises. And that will feel like a different conversation to me. Like that will be almost like when photography became invented, right? So when photography became invented, painters had to rethink, like, what are we doing? Like, is our job to create realism? And I think if machine learning reaches a point at which it can really, like, you feed it any number of images and it produces like thousands upon thousands of images of those same things, I think artists and everyone will have to rethink, like, what is the purpose of this, or what are we trying to do with these things, right? And this comes up in the art world, in the AI world, is a lot, where it's like, should we be producing fake images of people, right? Like that gets into like ethical concerns and other things. But I think it's also like a core fundamental thing of like, what are we trying to do with like this work? Is it just to prove we can? Are we trying to do something specific with it? Like, and that's where artists come into play. And I think that's where artists have a better grasp on like, what's the meaning of this, or what are we trying to explore with when we do these things? I think a lot of machine learning scientists and data scientists are actually really interested in actually inventing real, like, you know, global AI, or like, you know, like Terminator, like not Terminator, but like, you know, all thinking machines. And like, I honestly just not personally interested in that world. I'm interested in this world where like we've got some kind of shitty machine learning models that we can exploit and make weird things with. But this space of time might be 5 years, it might be 20 years, who knows? The truth is, it's actually been going on for a while. So it's like, we're already at year 25. It's just most of us haven't really realized that there were 22 years before this. So, you know, I just think it's interesting. I think there's a lot of potential for it, but who knows where it's going to lead, and who knows what the outputs are going to be going out. Dakota.
So kind of a part of that, and something that Leah also said there, are there any resources where there is active discussion in the community about ethics of some of these things, or about ownership? Because like that really interests me. My interest came from a different world. And you know, the other like sort of more questiony question that I have is like, I'm interested in reading about the ethics of how people are considering some of this, but like, if I understand correctly, like this person does not exist. Like the FFHQ data set is used to, people interrogate it to see if images, avatars exist inside the data set, and if they do, or exist inside the model, and if they do, it's presumed that they were generated by the model. Does anybody, you know, there's the talk of like copyright, because like a lot of us are just scraping images from not exactly public domain sources, but public sources. And does anybody do any work on interrogating models to determine what data set they were created with, to sort of try to adjust the ownership of the model?
Yeah, I mean, I think this is a big, within like the digital humanities community, I think there's a huge discussion about this stuff. I don't know a lot of those folks too closely, but there is one person who is like a pretty, is pretty commonly at SFPC, and her name is Caroline, blanking on her last name. Anyway, I will find her, I will find a link to her work. She does a lot
Caroline
of
Cinders, maybe?
Yes, yeah. Okay. Yeah, so she does a lot of work around sort of like ethics of AI and other things. And there's a lot of people who are like beginning to fill out those areas. There's also a group as a part of, I think, NYU, that is also like a whole lab of like digital ethics, like AI ethics. This is such a complicated area of discussion, and it's like, again, it's like kind of a thing where like I just put it aside for a moment. I'll bring up one example which happened this week, which is one of the people I listed on the Twitter community groups, which is ARFA. I don't know their real name, or if they even care to share their real name. They have a furry GAN. So they released a GAN that is all art from furries, from furry artists. And it received a big chunk of backlash because within the furry community, there is a sort of, I would say, a norm of you pay a furry artist to generate your fursona for you. And that is for you. It is like you own it, but like you paid an artist for it. So by him releasing this data set, it's sort of like, it pushed the community into like, what's the norm here? Like, is this breaking our norms? Like, there were a lot of people that were very, very upset with him releasing that, because one, he did scrape a bunch of furry art. People were very, or I don't know if he did or if he found a data set that did. So people were sort of like, you shouldn't be stealing from these artists. you know, it gets into the question of like, what is, you know, there's like legal scholars who have like explored this for 100 years around like, what is actual like fair use? What is creative? Like, I forget what the actual term
Transformative is the
yeah,
word.
it's
Right?
like it's like when you change, yeah, transformative, yes. Yeah, so like there's a bunch of exploration in this. My personal feeling is like there are certain things I care about and there are certain things I don't. I don't know that I like respect other artists, but I do believe that if I change someone else's artwork enough that it's fine. I think when we get into places of ethics of like FHQ is a good example of like they scraped Flickr, but like Flickr has inherent biases in it, and the people who did it like noted that as they were doing it, right? Like there are probably less people of color in Flickr than there are other people, right? Because like it requires a monthly sign up form. It requires, you know, people who have access to digital technologies. There's all these questions in like, what are the data sets we're producing? My feeling on some level is that by being artists instead of by working at Facebook or by like making this stuff at a big company, we're allowed a little bit more leeway in that we can, if we can acknowledge that these things are like, you know, artistic or that they have biases, but they are not having an effect on people's lives in the same way that say like a Facebook data set does, or like a data set that's being used by the police does. Like I feel like we have a little bit more leeway, but you know, with any of this stuff, there's always challenges, and we should be thinking about it as we're doing all this work. Martin,
Yeah,
go for
and
it.
also, I wanted to add something on to Dakota's question. There's also the a whole field called like image or data forensics, where like given an image that is potentially fake, people try to like track down like, okay, was this generated in what ways? Like, could this be like a fake adversarial image created by someone malicious? Like there's the whole talk surrounding deepfakes and like people having their own face spliced or like generated onto like porn videos and having that be released and that be unethical. And I think within like the research community, people are also discussing ways to mitigate that. Like that's part of the reason why I think these days people are not releasing as much of the entire source code and doing like staged releases and kind of being more protective as a preemptive measure to prevent like malicious people from downloading it and using it for that purpose.
Right. It's one thing if it takes researchers of a certain level for another state actor or whatever to be able to do those types of videos, but it's another thing entirely if like it's just released on the open internet and anybody can do it. Then you end up getting a much lower barrier to entry for who's able to create a deep fake, and it's no longer at a celebrity level, which is kind of where it's stuck to for the most part. Just because of the incentives involved around doing it for celebrities versus doing it for like just somebody that upset you.
Yeah, the deepfake, around deepfakes is like, it's pretty interesting because there's a whole community built around making deepfakes, and it's all very distributed and anonymous, but it's a very strong community, and they all contribute to like the same open source project related to generating deepfakes.
Yeah.
Yeah.
Thank you very much.
I was just going to add slightly to Derek's point about artists getting more leeway, which I agree with and I think is true, but there's a really sort of like difficult and worrying problem that happens when platforms become artists or content generators in a sense. So that I come from a music background, so I was got into ML through generative composition, and for a while I was pursuing. I had a PhD proposal and I was accepted, but I didn't get it funded, so I didn't end up doing the PhD. But a PhD was going to be in the ethics of generative composition. So for that, and I know for a fact that like Spotify will be doing generative composition, is planning to put generative composition on its platform soon, because they a year ago, I think they like employed this guy called Francois Pache, who was like the best in generative like mimetic like composition, not avant-garde generative composition, but like you want 1,000 more Beatles songs, here's 1,000 more Beatles songs, kind of thing. And they've employed him and combine that with there was all that thing they were doing with like non-existent artists, just like background piano music, and it's you put two and two together and assume that they're just going to be putting generative piano music.
I'm going to talk to you in the Slack about this because I have a bunch of stories about Spotify.
Oh yeah.
That's awesome. Yeah, I did not know that they hired. What's the name of the generative composition guy? What's his name again?
Francois Pache. Yeah.
Could you share it on the chat?
Yeah.
And just like one thing I think is worth mentioning there is like, okay, so I'm a product designer. So like, obviously I put on the product designer brain when I go there, but like, there's also a question of like, especially within the music community, like, or I would say like music listening community, like if I really, really like the Beatles, why wouldn't I want to listen to more music like that, right? From a listener standpoint, that there's an advantage to that. I think there's a tension there between like the artist who is saying like, well, wait, I don't want more of my music like that I didn't make made. But I think there's also the other side, which is like, there are people who want that, right? Like they have like listened to the entire Beatles catalog, they love it, and they just want more of that rather than like trying to find a new artist. So I think there's a tension there where artists also think that they are the owner and the creator of everything that they want to create, but like sometimes it's also like, I find a lot of artists who are just like very much like, no, I just make whatever I want to make, and it's like a little bit less of like thinking about what someone else might be interested in. So I think artists should be allowed to do both, or like should be allowed to say like, hey, I don't want my music copied and reproduced in like a generative fashion, but I also think there's a question there of like, who are you making stuff for yourself or for the audience, or like, how does that work? So it's a very convoluted space, and I think there's many arguments to be made in both directions. Esteban, I think you were going to say something.
Yeah, I would like to add two things. One, regarding the images that we're using. I am a collage artist. I've been doing this for several years now. And I know for real, as a fact, that if you change any image, these are the laws, the copyright laws. If you change any image, 70% from the real, from the real source is yours. Automatically is yours, and you can make it yours. That means that you change the concept, and you change the value of the image, and you can make it yours. This is written, so you can do this right now. So I think that the laws must change, and they have to understand how these technologies, these new technologies are changing. If we are creating these models and we are changing completely the source of the images, so it's ours, right? Well, I'm not interested in using other people's images to create my models. I design my own data sets from scratch, but I'm using, these people forks to create my data set. So that could be an issue somehow, or not, or maybe if I train it from the scratch, it would be totally mine. But I will, during the next months, I plan to continue designing my own data set. So I think that I'm in a different perspective. The second thing regarding the music is that I've been exploring and researching the work of Brian Eno. So I'm pretty sure that you know him. So he started creating generative music from the 70s. So he's been doing this for a while. And now he has an amazing app called Projection, which is $30, unfortunately. But you can have endless hours of music, of generative music, which is amazing. Ambient music, of course. So I don't think that there's any problem. The problem is that we are changing the tools. And in this case, the tool is machine learning or AI. We're changing the tools, and we are creating a different way to generate art. That's what I think. So people have to understand that we are using a new tool to create art. That's basically what I want to say.
Brian is a brilliant example of that. But I'd say there's probably there are two streams in generative music world. there are like artists like Brian Eno who are genuinely interested in like creating like new works and stuff. Whereas like I think that is very different from what Francois Pache is interested in, and they're quite separate for me at least anyway.
Yeah, I mean, I would say the analog for that in the image making community would be like someone like you, Esteban, who is using these as tools to make new images. That is sort of the Brian Eno side. Whereas like some machine learning engineer could come along and say, I've made 50 new Picassos and I'm selling them at this amount of money or whatever it is. You know, so it's like the intent matters, but like only to a certain extent, in that like at some point, like people will do like, you know, I think about this a lot as Leah and I are teaching these classes, right? Like I could, you know, there's an argument to be made that I shouldn't be making this content available to anyone except the artists that I'm working with, right? Like, I know you, like, I can at least like Google you guys and see that your intentions are correct. Whereas like me putting this stuff up on YouTube, like anyone could come along and say like, cool, now I know how to make faces, and now I know how to manipulate faces into like different ethical or like questionable ethics areas of like changing people's skin colors or everything. Like it's hard to just say like this once this information is available, bad actors and good actors can use it. And you have to sort of like be aware that like good actors will do good things with that stuff and bad actors will do bad things with it. So it's like, again, even inside the machine learning community, there are people who are like, well, let's just assume everyone is a good actor and make lots of stuff available. And then there are other people who say like, wait, it's clear that we have bad actors in this space, and we need to start building tools to defend our products against those, right? So this is, I haven't talked about that much in this class, but there's things called like adversarial images, where it's like, you could upload an image that like doesn't look like anything like what it's supposed to, and it will fake out a discriminator to do another thing. There are people who are just exploring that region entirely because it has huge like ethical concerns and other things. So, you know, this space as a whole is like just exploding, and like there's so many people in every part of it. And I would say like it's hard. I don't spend every minute of my day thinking about this stuff. Like I have a 9 to 5 that is very different from this work, but it's like I could very easily like spend the next 10 years of my life looking at this, right? And it's like everyone has to pick their point at which like, hey, like I'm actually just gonna only go up to here. Like up to here is where I'm ready to think about. And other people will be like, no, I'm gonna explore this whole other path. And for many of you, you may start here, and then in 5 years you'll be doing something else that is tangentially related or just a different aspect of it. So yeah, I think it's really interesting. I think there's a lot of exploration to be done here, but there's so many different avenues you could take this. Adam, go for it.
Yeah, mine was just like a little request for you, Derek. If you, like, I really want to do one of the GANSpace things tomorrow. Do you think you could just do a quick video of what you did today, but you don't even need to start the cells, but just from start to finish, the exact order that you go through? Because I tried earlier on in the week with the other, like with another version, and had a hard time with it. So if you were able to just go through and just do this one, replace this, and do that, that'd be really helpful for me. Because I totally want to finish up what I'm working on, and like at least that part in the next couple of days.
Cool. And I cleaned up that GANSpace notebook. The one I shared earlier that Sid first wrote was like definitely very messy and took forever to install.
Yeah.
So I cleaned up a lot of it. So it should be a little bit more straightforward, but I'll definitely do that. And just let me know if it's helpful or not. Yeah.
Okay, cool. And I just want to say thanks to you and Leah for the class. It was great. It's really helpful.
Yeah. Anything else from anyone? All right, well, Leah has posted the sign up form for our class. So I hope to see everybody in 2 weeks. Again, you don't have to present anything, but I would love for you to show up and like hang out and support the rest of the class here. Totally understand if you can't make it though. And again, please feel free to use our Slack as much as possible. You're welcome to DM me like at any point, or Leah at any point. Like I'll say after this class, like I will be a little bit slower to respond to everybody because I have a lot of catching up on my own work I have to do, but you know, I'm happy to like try to respond as quickly as possible with things. And then please fill out the survey. It's really, really helpful for us to know what people enjoyed, what people didn't. I think we're probably going to eventually do another StyleGAN class, but I'm not sure when. We might also be doing some stuff that will sort of be tangential. Like I'm really interested in doing a StyleGAN class, although no one else has ever shown any interest in it, but we'll see. So yeah, if you're interested in anything, like, please let me know, and I'm happy to sort of like try to find opportunities to do this. So also like I'm interested, like, so this is a 5-week class, so it's clearly like intense, but also like right now none of us come to the house, so maybe that's good. So if you're interested in like a shorter class or a longer class or whatever, like please let Lyra I know, and we're always trying to figure out how to like sort of change it up and learn from what the next class will be. All right, so with that, thank you everyone so much. I'll see you on Slack and hopefully in 2 weeks.
Thanks a lot, guys.
Thank you very much.
Thank you guys.
Bye everybody.
Thank you, guys.